Hello friends and welcome to a lecture on operation research. Today we'll be taking up a transportation problem and we will solve it using the Vogels approximation method. The problem is on your screen. A dairy farm has 3 plants located in a state. Daily milk productions at each plant is as follows. From plant 1 it is 6, plant 2 the production is 1 million liter and plant 3 the production is 10 million liter. The demand in the distribution centers is in distribution center number 1 it's 7, distribution center number 2 it's 5, distribution center number 3 it's 3 and distribution center number 4 it's 2. The cost of transporting milk is given in this table. So how is this table understood? Supposing we want to transport milk from plant 2 to distribution center number 3. It's going to cost me 6,000 rupees per million liters. Let's say if I want to distribute milk from plant number 3 to distribution center number 2, it's going to cost me 8,000 rupees for a million liter. And all other entries have the same meaning. So let's see how we can solve it using the Vogels approximation method. So the first thing that we need to do is copy down this table, and I have already done it here. So let's concentrate on this table now. With the table in our sights, now let's understand what is the concept behind the Vogels approximation method. In Vogels approximation, what do is we calculate the cost penalty in each row and each column. Now, what is a cost penalty? A cost penalty or a penalty is the difference between the second highest cost entry or second highest entry in a row or column and the least entry. Okay. So, for an example, let's take row number 1. In row number 1, the least entry is 2 and the second highest entry is 3. So the penalty here is going to be nothing but 1. Okay. Now the penalty in row number 2 is also 1. The penalty in row number 3 is going to be 3. Okay. The penalty in column 1 is going to be 1. The penalty in column 2 is going to be 3 because that's 0 minus 3. Okay, the penalty in column 3 is going to be 5 and the penalty in column 4 is going to be 6. So let's draw a line. Okay, now what we do is we take the highest penalty. Now the idea of taking the highest penalty and allocating supplies to that is because if we don't do that, okay, then what is going to happen is supposing we do not go for the row or the column where the penalty is highest and do not give the supplies there and give it to next, it is going to increase the cost of transportation. Why? Because we have neglected the penalty. Let us say supposing while we are allocating it goes to the next highest cost. So the penalty or the cost is going to shoot up dramatically. So we have column number 4 which has the penalty 6. So the least cost here is 1. So we give 1 million liters to cell number 24, right? Therefore, now what we have here is, okay, in distribution center number 4, 1 liter demand remains. But plant number 2, essentially all the supplies of plant number 2 has been exhausted off and now this is out. Now we have to recalculate the penalties. So let's recalculate the penalties now. So when we recalculate the penalties, obviously penalty in row number 1 is 1, penalty in row number 3 is 3, but the penalty in distribution or column 1 now is going to be 2 minus 5, that is 3. That in column number 2 is going to be 5. column number 3 is going to be 4, and column number 4 it's going to be 2. So where do we have the highest penalty now? The penalty highest is in column number 2. Now in column number 2, the least cost is 3. So we have to assign the supply to this. The demand here is 5. The supply here is 6. So what do we do now here is we allocate all the supply to the demand, that is 5. Okay. So the demand of center number 2 has now been satisfied. So we strike out center number 2, or the column which has center number 2, because essentially everything has been done, right? So now what do we have is, okay, we again draw a line and we recalculate the penalties, and we have to keep doing this till we have taken all the supply and given it to all the demands. Okay, so let's go about it once again. Now, the penalty in row number 1 is going to be 2 minus 7. So that's going to be 5. That in row number 3 is going to be 4. Column number 1, it's going to be 3. Column number 2, everything satisfied, so need not be considered. Like row number 1 is not being considered here. Okay, now column number 3, it's going to be 4. And column number 4, it's going to be 2. Right? Now what is the highest penalty here? If you go to see 3, 4, 2, 5, 4. So the highest penalty here is 5. That is row number 1. Right? Now we had already assigned 5 liters to distribution center number 2. So 1 million liters remain. Now this 1 million liters is now assigned to cost 2 because this is the least cost. Now the demand of distribution center number 1 is now 7 minus 1. That makes it 6. Right? Now we have to strike out row number 1 because plant number 1, all the supplies have now been exhausted off. Right? What remains now is only the third row. Right? So here we need not go in for calculation of penalties because there's only one row and the supply of this row needs to be adjusted to now the remaining demands. Okay, now going back to the least cost. Now from 10, the least cost here is 5, but the demand here is 6. So we assign 6 here and that's it. It's done. So we are left with 4. Now the other part, that is 1 from this, goes to the next highest cost. So that's going to be 3. And then this 3 is going to now get allocated to the next highest cost. So this demand has been satisfied and this demand also now has been satisfied. Right? So as we can see, all the allocations now have been done. Now, is this an initial feasible solution? Initial feasible solution? Yes. It is an initial feasible solution because the number of allocations is 6 and this is equal to the number of rows, that is 3, plus number of columns, that is 4, minus 1, that is 6. So this is an initial feasible solution. The allocations are 6 and the independent constraints are also 6. Now, so let's go ahead and calculate what is the cost now of supplying. So the cost is going to be now rupees 1000 into 2 into 1 plus 5 into 6. That is the cost multiplied by the allocation, right? 5 into 6 plus 3 into 5 plus 15 into 3 plus 1 into 1 plus 9 into 1. Right? So what do we get now? Rupees 1000, 2 plus 30 plus 15 plus 45 plus 1 plus 9. That makes it rupees 1000. So 15 and 45 make it 50. Okay, 9, 10 to 12. So that's 12 plus 15 plus 30. So that's it. This is 10, this is 2, so that makes it 12. So we are now remaining with 30, not 15. Okay, so let's remove this out. Yeah. Okay, and we have 50. Yeah, 50 plus 30. So that makes it 102,000. Okay, so a better way to write it would be, of course, rupees 102,000. So the cost now is rupees 102,000. Now you can see the link for the northwest corner method, and the other methods have also been discussed in the playlist. There are a couple of other methods also. So we are way low than all the other methods that we had used. So 102 is a very good approximation. Okay, but this gives you the initial feasible solution. This gives you the initial basic feasible solution. It's also known as the initial basic feasible solution. Now, can this be further optimized? Yes, it can be further optimized using stepping stone method, Modi method, and this is discussed in the playlist. You can go and have a look at it. But Vogels method, Vogels approximation method, does give you the best initial optimized cost for your operation. And that's the beauty of it, because it works on the idea of penalty. So that was all about Vogels approximation method. If you like this video, give it a thumbs up and subscribe my channel. Keep watching. More such videos on operation research will come up. It's going to be a very interesting journey. Operation research is something which routinely engineers and managers apply in practice, because it's all about cost optimizations. And everybody today, every company, every industry today is now just bothered about cost optimization, delivering the right product, but yes, at the most optimized cost. I would not say the least cost, the most optimized cost, because quality is also a concern. So that's all, friends. Goodbye. Have a great day. Have a great time.